Well, difficult for me to answer on behalf of the chemical sector, but as a chemical sector company, quite easy to understand. We are very upfront in the value chain, so we deliver material and solutions, formulation to our customers that will transform them to a certain extent so that they will be used by their customers, etc., until they reach the consumers, a car user, someone buying a car. So circular economy SDGs for a chemical actor, it means what? It means that, we like it or not, it will change completely, it will transform our lives. As citizens, as consumers, we will move from I need to own a car in order to have my neighbor looking at my car, to I need to move from one place A to place B, and mobility as a service. So this means something in terms of material, but this also means something in terms of the how much and the ownership of the materials. Uber today, it's completely dematerialized. Nobody in Uber is owner of the car. Somebody else is owner of that. So it might be at one point very simple, such as, well, we need more effective material because moving from family E to family B, we do not to have the odor remaining in the car and therefore new. But it might be much more sophisticated, as those cars will be entirely made out of recycled material because this is a distinctive selling proposition for company A compared to company B. So it is quite central in our future. If we take the challenge right, we have a chance to be successful and more successful than the one that are not taking the challenge right. It's an interesting question. So up to now, we have 3 experiences where we try to implement new business models, really something really new, and out of the 3, 2 failed. So we invest money in a plant in France in order to reaccess rare earths from low economy bulb lamps. So we invented with others, we invented the technologies and set up in place the supply chains to access to those materials, and ultimately realized that the economics were not right, meaning that the market has returned for rare earths, and it was not worthwhile to continue the operation, and those have been stopped. Another example, which is that one successful, is the manufacturing of polyamide compounds out of scraps from airbag production. So we're turning waste, but well-defined waste. So we come back on that later. Waste, chemical science is applied to it, so it's not a mechanical grinding. There is no added value for the chemical companies in there, and we do reaccess the molecules from which we do remanufacture polyamide with the same characteristic as the virgin polyamide, so the one being made out of the classical non-renewable material or not recyclable material. And to deal with one problem at once, we start with those scraps, not trying to collect polyamide being used many times for long in a car, as an example, but because we deal with only the impurities that are coming from the manufacturing process of the airbag, the other ingredients that are added in the manufacturing of the airbags, we deal with it. And when we will not have enough of those raw materials, then we will enlarge it progressively so that we add a layer of complexity, but only one layer of complexity. That might be another producer of airbag and using scraps, but it might be something different. But we try to keep it as simple as possible when it makes sense.